All right, I want to give you lots of help on this lab because I think you're going to need it. The picture you did page 2. How about page 3? First thing off is that 7.13 gram, the mass of the marble turns out to be 0.00713 kilograms because you move it over 3 places. That's right, okay. I think, I'm not sure, one class did this already, but how do you, if just in case you didn't do this, the vertical drop of the marble was this. The VIY, because it was projected horizontally, is that. The time is what? That's what you want to find. And of course, the acceleration due to gravity is 9.8 positive meters per second squared. The fit on that one would be di equals 1/2 at squared. You've got the dy, you've got the a, and that's how you can find the t. I think it's about 0.4 something. Next thing you have to do is to find the horizontal and vertical velocities of the left and the right marble. So the left marble, the marble that went to the left. Now, look, people were talking about what do I call the left marble. You go to your picture here. Go to your picture and establish what your left marble. You had something like this, right? If you want, call this your left marble. In fact, label it. And if you want to call this one your right marble, fine. That's good. Also, unfortunately, I talk about a marble 1 and a marble 2. How about you can label it any way you want, but that I'm going to call that left one marble 1 and the right one marble 2. So sorry about that, 2 designations. So do label that on the picture. So anybody reading your graph would know what you're referring to when you talk about the left and the right marble and the marble 1 and 2. So how do you find the horizontal and vertical velocity? Well, the same way. The Vx for the left marble. Now, Vx equals dx divided by t for the left marble, and the Vy would be dy divided by dt. Unfortunately, so you go over here, and you got a left marble and a right marble. Make up a number. So maybe your dy is, totally making it up, 0.15 meters, and your dx is 0.25 meters. So how would you find your Vy? Remember I said that's 0.15. Vy is 0.15, so it would be 0.15 meters divided by, I think this is like said 0.4 something. 0.4 something, and there's how you get your Vy. Then your left marble has an x component in meters, so let me make that up. Let's say your x component of your was 0.25 meters, and your time would be 0.4 something seconds. So let's go back over here. This is marble 1, I guess. Is that what I'm doing? No, the left marble, which is the marble over here. So 0.15 and 0.25. I guess I did. I came up with these phony numbers. So there you go, whatever that turns out to be. Then the right marble also has 2 components. It has a y component and the x component. You have that in your picture. Let's say this is like 0.22 meters, and this is 0.35 meters. Well, you do the same thing with marble 2, or what I'm calling the right marble. Again, you're using the same time, but you're using your x and y components, and you're dividing it by the t, and you'll get your velocity, your vx for the left marble, and your vy for the right marble, and each component. Now, how do you do the px? Well, px equals m, the mass of the marble, times vx. Where are you going to get vx? Right over here. That's more. Are we calling the left marble 1? Let's see. Sorry for being so confusing. Yeah, we're calling left marble 1. So there you go. Now, what is the mass? The mass is right over here, right there. Mass of the marble. All these calculations is the same value. So px for marble 2 is the mass of the marble times vx marble 2. The py is the mass of the marble times the vy. We're going to get these vx's and vy's. We're going to get it over here because you'll have calculated these left and right marbles. All right. So then you do it again. Marble 1 and 2 have x and y velocities. So marble 1 and 2 have x and y momentums. What's the total horizontal momentum of the marbles after the collision? What's the total? Well, with the horizontal momentums, I think what we did is I'm pretty sure we call that y, that x. Your total horizontal momentum is, remember when you do that, you're going to make, let's write a little note to say, so one is going to be positive and one is going to be negative. And you might say, well, which one do I make positive or negative? Well, you could make this anything going to the left negative, and everything, if you want to be conventional, anything going to our right is positive. I don't care what you do. You got to call one positive, one negative, because they are going in opposite directions. So whatever convention you decide, then you'll find the total momentum after. And then the vertical momentums, where they're both positive, because look, they're both velocities are positive, you see? This has got a positive velocity. This marble's got a positive velocity. And this marble has a positive. So then you go down over here and you'll have some total vertical momentum that's greater than each one of the vertical momentums that you found here. That'll be larger. Use your law of conservation of momentum to explain why one of your momentum totals was actually close to zero. Well, look, I'll give you a hint. The total momentum of one of your directions must be close to zero. Why? Because the only momentum, when the marble rolled down the ramp, that represented the total momentum before the collision. That marble rolling before it hit something is the total momentum before. And isn't it true that the marble rolling down the ramp only had what we'll call, by our convention, y momentum, right? It was only going the y direction. The marble, before it hit the second marble, it only had y momentum. It had no x momentum before the collision. So you know what? Even after the collision, the total x momentum still has to be zero. Now, it was probably not true. I think there was one group, or two groups it was actually true for. It should be close to zero for many of you, but probably I think it was just one group. It was actually pretty close to zero. So don't do that data table. Don't worry about it. And then you know what's cool too? Stop at 4. You're done after 4. Good luck, girls. Make sure that everybody you talk to watches this video, because it's a heck of a lot easier to do this lab if you looked at it. I'll see you tomorrow. Bye-bye.